All right, welcome back, everyone. Today we're tackling a really cool problem from the German Math Olympiad. And yeah, at first glance, it looks like a total mess. But I promise you, the solution is just, well, it's beautiful. Let's do this together.
Okay, so here it is. This is what we're up against, and the rumor is that only 1% of people can actually solve it. You know what? I think we can prove them wrong. This isn't about being a genius, it's just about knowing which tools to use and when. So, where do we even start? Well, with equations like this, full of exponents, the number one rule is to simplify. And the best way to do that is to get everything on the same team, to find a common base. And if you look closely, those numbers, 4 and 8, are practically screaming that they're just powers of 2. And just like that, we can rewrite the whole thing. The 4 becomes 2 squared, and the 8 becomes 2 cubed. We haven't changed the value at all, but look at the structure. It's already so much cleaner. This one little change is the key that's going to unlock the entire problem. Okay, so to deal with those new parentheses, we need to pull our first tool out of the toolbox. It's the power rule of exponents. Super simple, but super powerful. It just says that when you have a power raised to another power, you just multiply them together. So when we apply that rule, watch what happens. The 2 squared to the x becomes 2 to the 2x. The 2 cubed to the x becomes 2 to the 3x. And boom! All those messy parentheses are gone. Much better. All right, time for our next tool. We've got 3 different terms, but they all share the same base, which is 2, and they're all being multiplied. This is a perfect job for the product rule of exponents, which will let us squish all 3 of them into one neat little package. And here's that rule in action. Since the base, 2, is the same for all of them, we just have to add up the exponents. So we get x plus 2x plus 3x. Just like that, 3 terms have become 1. So after adding those up, x plus 2x plus 3x, we get 6x. Our entire equation has been boiled down to this one simple expression, 2 to the power of 6x equals 40. I mean, look how far we've come. But now what? And this is exactly where a lot of people get stuck. We can't divide by 2, we can't divide by 6. That x is basically a prisoner up there in the exponent. To get it down, we need a very special key. And that special key is called a logarithm. I know, they can look a little intimidating, but trust me, logarithms were literally invented to solve this exact problem, how to free a variable that's trapped in an exponent. Think of it as the ultimate escape tool. So let's use our new key. You know the golden rule of algebra, right? Whatever you do to one side of the equation, you have to do to the other to keep things fair and balanced. So we're going to take the logarithm of both sides. Now, you might be asking, okay, but why did we do that? Well, it's because of this amazing trick right here, the power rule of logarithms. This rule is like magic. It lets us grab that entire exponent and just bring it down in front as a regular number. And there it is, the x has been freed. Our exponent that holds 6x is now down on the ground floor with the rest of the numbers. Now we can finally work with it using regular algebra. This right here is the biggest turning point in solving the problem. So from here on out, our mission is simple. Get x all by itself. To start, let's divide both sides by that log of 2. That leaves 6x alone on the left side. We're getting closer. Now, we could just plug this into a calculator, but where's the fun in that? Let's solve this thing elegantly. We can simplify that log of 40 using another handy rule, the product rule of logarithms. It lets us break apart a logarithm of something being multiplied. So let's rewrite 40 as 8 times 5. Now, you could use 4 times 10, but I'm choosing 8 for a very strategic reason, and you're going to see why in just a second. Using our new rule, log of 8 times 5 becomes log of 8 plus log of 5. And here's why we picked 8. Because 8 is just 2 cubed. By rewriting the log of 8 as the log of 2 cubed, we've brought our original hero, the number 2, back into the equation. Whenever that happens, you know you're on the right track. Now check this out. Because we have log of 2 cubed, we can use that awesome power rule for logarithms again to bring that 3 down in front. So our numerator is now 3 times log of 2 plus log of 5. This is perfect. Because our numerator is 2 things being added, we can split this big fraction into 2 smaller pieces. And look at the first piece, 3 times log of 2 divided by log of 2. The log of 2 just cancels out, leaving us with a nice, simple 3. How clean is that? We are so close. We just have one final tool to pull from the kit. It's called the change of base rule, and it's a fantastic little trick that lets us take a fraction made of 2 logs and combine them back into one single, much prettier logarithm.
So when we apply that rule, log of 5 divided by log of 2 becomes log base 2 of 5. And just look at our equation now. I mean, after all of that work, the entire problem has been distilled down to this one beautifully simple line. We are on the home stretch.
And now for the easiest step in the whole problem. To finally get x all by itself, we just divide both sides by 6. And that's it. That's our answer. We've done it. We've solved the German Math Olympiad problem.
But of course, we should always double-check our work. So if we take our answer for x and plug it back into our simplified equation, 2 to the 6x, you can see how everything cancels out beautifully. We end up with 2 cubed times 5, which is 8 times 5, which is 40. It's a perfect match. We know for sure our solution is correct.
So that problem that supposedly only 1% of people could solve, turns out it wasn't really about being a genius. It was just a puzzle waiting for someone with the right keys. It just goes to show you, with the right tools and the right rules, no problem is ever truly impossible. It's just a series of locks waiting to be opened.